Okay, good afternoon again. Let's start. Thank you very much for joining this. I'm quite humbled to see so many famous names in this webinar. So many of my friends, many of my clients, and many people that I actually attended their presentations are here. So thank you. This presentation has actually been delivered this year in February at the 3D Experience World 2021, which is, as you know, the replacement of SolidWorks World, or SolidWorks World expanded. What was different this year compared to the previous years is the fact that it wasn't in person, it was all virtual. So it was a different experience also for a presenter. We were asked to condense what we usually would deliver in 90 minutes in a live presentation, a video that could not be longer than 30 minutes. So it was a lot of information dump, but in a way that was hopefully still useful for users. And then we had a 15 minutes live Q&A, question and answer sessions to clarify things that we weren't able to do in those 30 minutes. Now, looking on the list of names that are joining us today, I see quite a few of you who already attended this presentation. So I imagine those 30 minutes weren't enough. So today we're going to do a live presentation with all the dangers that a live presentation can do. We'll see. Hopefully we're not going to have things that are going to take forever to happen on the screen. But also it's going to give us the chance to be more relaxed and you the chance to ask questions. So please use the chat. Ask as many questions as you want, and we will try to answer all of them today. And today it's all about working with imported geometry. So before that, just in case we didn't have a chance to meet each other, just want to introduce myself. My name is Alin Vargatu, and this is wrong. I'm not a large assembly wizard. I'm a grand wizard of large assemblies. These large assemblies really have become my passion for the last almost decade. And that's because whenever I visited a customer to help them with SolidWorks related issues, to help them become faster, to train their teams, about 80% of them in the end would tell me, listen, this is great, but you see what I'm doing right now, I'm trying to open this assembly, it's taking ages. Or I already opened the assembly and now I'm trying to change something to it. And again, I have to wait and wait and wait. So I became curious, why is that happening? And I learned from these interactions with my clients, and many of you are in this meeting, so you will know exactly what we are doing there. I learned a lot from you, so thank you for that. And in return, as I build more experience, and my team also build more experience from the interactions with our partner, with our customers, we are able to give more back. Now, you know that we have all type of large assembly services where you are having us as pretty much like a private consultant. So we work with your assemblies, we work with your team. Nobody else benefits from that. But we noticed that many of the things that people are complaining are very similar. So in the last year or so, we packaged some of this information in public workshops. One of them is the large assembly and drawing workshop. It's a 2-day worth of investment of time. So really are half days, so 4 half-day sessions. I think the next one we're running, it's in July, if I'm not mistaken. And the course that I'm working right now, which is optimizing, import geometry optimization. So hopefully we're gonna be able to launch this also very soon. Other than large assemblies, if I am to continue to back for another minute, I like to be part of the SolidWorks community. I consider myself a user first. I learn a lot from other users on the forum, on the blogs, on the videos, on presentations like this, or at SolidWorks World, or user group meetings. And also I'm learning a lot from the questions that are being asked on these forums. So we at Javelin and TriMech are trying to give back as much as possible to the community, and this is one way of saying thank you. What else? Oh, there is one cool thing that I haven't mentioned there because I didn't know when I wrote this presentation for SolidWorks World, is that this year at 3D Experience World, I was honored receiving the title of Application Engineer of the Year for the SolidWorks user groups. So thank you very much for those of you who voted for me and for Javelin on that behalf. So let's keep going. Now let's start. Enough bragging, right? As many of you know, I work for Javelin Technologies. We are the Canadian VAR, so you can see our location here. Now, not all of them are brick and mortar. For example, here we have dedicated application engineers, same thing out west. One thing that is not shown here, but I would like to share with you is a piece of news. And I'm very, very proud of, actually very excited about this. So if I'm going to my website, Javelin Technologies, I don't know how many know that now we and TriMech are one team. And you know what's cool about this? If you are our customer or TriMech's customer, take a look at the time zones that you guys are getting support on. So you can see from Newfoundland, actually from ocean to ocean, really. So it's crazy. It's like you're getting 13 hours or 14 hours of support. So our new customers from US, I guess, are going to be the happiest because now we have qualified application engineer to serve everybody. Very excited about this and looking forward to meet more with clients from United States. So I'm going to update this slide. I have to add so much more information here. So cool. Now, in our actual training course, so when you join, let's say, the large assembly course or especially the new course that I'm going to make about imported geometry, an ideal agenda would have to be very thorough. So first of all, we would analyze how you would use step files, IGES files, Parasolid files. What type of files are you getting from your suppliers or from your customers? I downloaded them, right? What exactly are you doing with the step file? Would you just open it and then save it as a SolidWorks file and just put it in your assembly? Is this all you do? Or do you work with somebody else who has a different CAD software? So they would send you, let's say, revision 0 of their step file or of their model as step file. You will put it in your part or in your assembly, right? And you start working, you start building around it. And then they say, hey, we changed something, so let me send you another step file. What are you going to do then? Is there a quick way to quickly update your geometry and also see what's different between the old one and the new one? And even more, make sure that any maze that you apply to that new step file, or actually the old step file, will still work with the new step file. So very, very interesting. We're going to analyze how you're going to use the step file. Then we will cover ways to import. And when I say step file, I'm talking about any type of imported geometry. Okay, I'm going to use the word step instead of imported geometry. So as you know, SolidWorks has actually two different engines for importing step files. Like the traditional one, the one that we used to use up to SolidWorks 2017, it was only one way to load the step file in SolidWorks. Now we have two ways. So which one is better? When to use one, when to use the other, right? So we're going to talk about that. Then speed. Many of you came to us complaining that you try to open a step file and it takes a day. Or sometimes the import doesn't complete because SolidWorks crashes. So are there ways to optimize the speed? Are there ways to make sure that the operation completes without crashing? Then after you imported everything in SolidWorks, many of you and many of us like to have perfect geometry, right? We want solid bodies if possible, no topological errors, no faces that go through other faces, no crazy surprises, no gaps. So how do we ensure that just on import, you pick up the right settings to get the best quality possible? And if by any chance you still have errors, how to find them first of all, how to assess if they are going to be impact your performance, because some of them we can live with, others are going to destroy your performance, not only with assemblies, but especially with drawings. And then how do you fix them? I mentioned the revisions, right? So somebody changes the original file. How is that going to affect you? Do you even know what has changed in the file? Do you need them to send you an email? Okay, I changed this hole and I moved that face 5 millimeter and I cut away that part. Or can you press a couple of buttons and quickly see the differences between the revised files, the original and the revised file? Also, how do you preserve, as I mentioned, references that you already applied to the previous revision? And last one, import optimization. So after we got all of this in SolidWorks, I might not even have the step file anymore. I just have a bunch of imported features in my part, or an assembly that has lots of imported parts. And then I put that in my SolidWorks assembly and suddenly everything stops. Everything becomes so slow. How can I optimize the file, the imported file, in such a way that I'm getting the information that I want, but it doesn't impact me on performance? So this is the ideal agenda if you join our course. Now, we don't have that much time here. So I'm going to show you the 30 minutes to 1 hour agenda. We're going to skip directly to step number 7, right? Import geometry optimization. So when you complain about large assemblies in general or working with imported geometry, there are two types of complaints. You say, well, this takes forever to load, or, yeah, you know what, I waited those 30 minutes to load the assembly because I have this imported geometry in there. But now I try to click on something to apply a mate, two faces. And you see it takes 2 minutes for those faces to be selected. And then I click apply mate. And it takes another 30 seconds for those faces to get together. So you experience this continuous lag that is destroying your performance. So what can we do? Well, there can be many reasons for slowdown. So in this presentation, I'm going to focus only on 5 of them. Okay? And I hope you can understand this little chart. I put it together like that. So green, low impact, yellow, medium impact, red, big time impact. Okay, so we'll take a look at some of these factors, like number of face appearances. It was a big surprise for me how much having a step file loading with the defaults can impact you if the colors or the appearances are applied at face level. So I have customers who have one part that has close to 100,000 appearances applied to faces. But I wasn't expecting that to impact SolidWorks. When I went to SolidWorks World in 2016, I believe, I forgot where it was, I think LA if I'm not mistaken, and I did a presentation on large assemblies. Somebody from the audience came to me after the presentation and said, did you know that appearances can slow you down? I said, I didn't know that. Let's find out. And he was absolutely right. It's, for me now, this is kind of #1 problem. The good news is I got in touch with the R&D from SolidWorks, and I'm trying to convince them that this is a big problem. There is already an SPR there. It's just a matter of getting the right people to work on fixing this. Because we want colors, right? And we don't have to spend a ton of time fixing them. Topological errors. So that would affect mostly drawings. When I say topological errors, is let's say you run import diagnostics, and you're gonna have a bunch of faces that are failing. The problem with that, especially in 2020 and 2021, is that SolidWorks drawings wouldn't be able to compute their edges using the body data because the bodies are invalid. Right? SolidWorks doesn't accept faces going through each other, for example. So what's going to happen to the drawing views that are calling for those parts? So imagine you have a little part in an assembly and that part has a topological error. Most likely the drawing view that calls for that assembly is going to be shown in draft quality mode. So it's going to have the edges computed based on the sides of the graphic triangles that are on those faces. And that destroys the functionality that we are so proud of now, called detailing mode. Because instead of having a clean edge to which it's easy to attach information like this edge belongs to this face belongs to this part belongs to this assembly. If you put a balloon, this is going to be balloon number 73. If you select the edge, you can dimension it. Now there are going to be a bunch of little triangles all over the place. And those are very hard or impossible to dimension, impossible to balloon, impossible to attach nodes. If you save the drawing, it's going to take forever if you save the detailing data. So this became my #1 enemy when I help my customers who are dealing with drawings. The other thing that's good to know is that if you run delete face, or move body, you are increasing significantly the file size of a part. So I think I can demonstrate that. I know I'm boring you with PowerPoint, so let me go to SolidWorks. And let me open this part. Okay, so you can see it's an imported geometry part. I'm also going to run import diagnostics to make sure that everything is fine here. So hopefully we're going to see a green report, so everything is fine, right? Now I'm going to save this. So you can see it's saved right now. Let's take a look at the file size. So I'm going to press R, recent documents, show in folder. You guys know that if you took my course, and you find out that this is 199 kilobytes. Now I'm going to delete the face. Which one should we delete? So let's pick a simple one of these holes. Okay, using the delete face command, which many of us are using. All right, so sometimes you think that I can run delete or delete and patch to clean geometry. Let's see the effect of that if you apply the delete face command on an imported feature, not on any other type of feature, but something that started from an imported feature. I'm going to hit save. Remember the size of the part before? It is something like 190 kilobytes. Now it's 255. That's an increase of 25% or more. In some situation, you're going to see this number double. Why is that? When you run delete face, or move body on something that has imported geometry, SolidWorks makes a copy of the body data. So kind of, it tries to protect the original data coming from the step file. It's going to leave it there the way it is. It's going to make a copy, and then any operations that you do to that part are going to be done on the copy, just in case you ever need to come back or something like that. So that's the only thing you have to remember. If you run delete face, move body, or delete face or move face, so delete face, or move body, expect to increase the file size. So this is a simple file. In other files, it's going to be much more complicated. I'm not saying don't use these tools. I mean, at this point, I can probably save this out as Parasolid, bring it back, and I'm getting back to imported one. Fortunately, then there is an easier way to do that without having to run imported one. So let me delete this delete face. Right, so let's check again the file size. So right now we have it as, oh, I closed the Windows Explorer. Okay, let's try again. Is 255, right? So now if I hit save, goes back to 199. Okay, now I'm gonna still delete that face, but I'm gonna use a different approach. I want to modify directly the information that came from the step file. So you do that by starting import diagnostics. So it's gonna save, all the faces are nice and everything. The cool thing about import diagnostics, the name is wrong. This tool is fantastic, not only for finding problems, but also for modifying the information that came from the step file. So I'm gonna select this face, and I'm simply gonna delete the face. Instead of running the delete face command, which adds a feature in the tree and increases the file size, I'm running delete face inside the import diagnostics. That is like a direct editing on the step file, on the information that's coming from the step file. The result is still the same now, it's a surface body and everything, right? So let's take a look at the file size. So it's 199 before I hit save. hit save, and it's just 1 kilobyte more. It's 200 instead of being 255 or 300 or something. So in effect, by doing this, I'm still working with the original imported data. Try it if you don't believe me, and see how it works. Okay, let's take a look at the next thing. So the other two factors are something that you probably are expecting. Like if a part has lots of bodies, each body in SolidWorks, believe it or not, but it's like a separate part. So if I put a new multi-body part and I place it inside an assembly, for many computations that happen at the assembly level, each body has the same bearing as one part. And then the number of graphic triangles. So those are things that many of you are very familiar with. Let's take a look at some. Let's go one by one. So I have the same assembly on the left, on the right. You cannot really tell the difference. It's 11 minutes to load. This one takes only 2 minutes. Actually, I think I can open it faster than that. So I don't want you to wait 11 minutes with looking on the screen right now. So I took the time to open this ahead of time. So I have here actually two SolidWorks sessions running side by side. I'm running 2021 Service Pack 3. And let's go to the performance evaluation on the one on the left. Right? And let's go performance evaluation on the one on the right. And I would like you guys to pay attention to the reports here. Isn't this crazy how this part took 195 seconds to load, while this one took only 10 seconds? That's surprising. So let me actually, I think I recorded a video where I studied this opening side by side. Right, so you can see I'm opening the one on the left first, I think, and then the one on the right. So right now you're gonna see the preview of the files, right? That's the first thing SolidWorks does. It loads the graphics data that has been saved inside the SolidWorks file. And then we're gonna speed up this video once we get the preview. All right, so now let's go warp speed. You can see the one on the right, it opened already, 2 minutes and 26 seconds in this case. The one on the left, let's speed it up. Let's find out how long it's gonna take. All right, so keep going, keep going, keep going. Faster, faster. Wouldn't it be nice to be able to speed up the opening of SolidWorks like we used to have the turbo button, if anybody's as old as I am at computers a long time ago? When you had a 286 or a 86, just go turbo, so the game will go faster. So this one was 15 minutes. That's crazy, right? So let's find out why that is. And let me use the one that was slower. So under performance evaluation, one thing that performance evaluation can tell you, among many other things, is appearances. So any documents that have more than 100 appearances apply to faces. It's like every little face was painted nicely, different than the other faces. Let's show these files. So instead of taking the whole body and dunking it in paint, I'm painting every face one at a time. Or maybe imagine decals. Every face is painted like that. So you can see here, I have 1, 2, 3 parts that have almost 10,000 or more appearances applied at the face level. And this is not a lot. I saw other parts from other customers of mine, and looking over here, I see at least one of you is here in the presentation who had 60,000 or more appearances. Now the cool thing about this, I can hit the open button to open the parts, right? So let's open only this part to take a look at it. And once it's open, I'm going to close this window. You can see the opening time for a part that's already in the memory takes a long time, right? So you can see it here. If I'm going through the display manager, this is where the appearances are listed. I have 9 appearances, nothing bad. Let's go by hierarchy. So I want to see faces, bodies, features, parts, things like that listed in the appearances. So you can see faces, all right? So there are 2 appearances that are applied to faces. If I expand this, let's see how many faces are in this appearance. You can see 1,000, 1,000, 1,000, 2,000, right? If I expand this one, again, thousands of appearances. And I have a feeling that not all of them are being reported right now. So what you can do, if you don't care about the colors, you can simply get rid of all of them. If you need to preserve some of the colors and then reapply them to bodies or to parts, we can show you in the course how to do that very easily. So how do you get rid of all the colors? There are 2 ways to do it out of the box. So one is right-clicking on the top name, going to the appearance and removing all part appearances. Just be aware this is time consuming. So if I do it right now, we have to have several people saying jokes or singing songs or something like that, because it's going to take a long time and we're going to get bored. The other thing you can do, you can right click in the configuration manager or display state space, and then use the option to remove all display states. Okay, so that will automatically wipe out all the appearances. Even this, for this specific part, is going to take about 3-4 minutes. So I'm not going to do this. Okay. What I'm going to do instead, allow me to close all these files. Actually, allow me to close the main assembly. So at least we're not going to go back to it. Hopefully this is not going to take forever. Mind you, I have sessions of SOLIDWORKS running at the same time, so we'll see how that works. The other thing that this appearance is going to impact, and I'm glad that you see this, is the fact that when you go from one window to another, if I were to switch the assembly, you might see even the assembly graphics being computed again, right? So I already saved this as a different, as a part with a different name. And I think I already wiped out the appearances using that option to delete all display states. Okay, so now I'm loading the same part, but a part that has only one appearance. But we don't have the time for you guys to see how long it takes for this part to load and how short this part is in loading. Let me see if I did capture. No, I didn't capture. Probably we can make it happen. So one thing I can do, I can put these 2 parts inside the same assembly and then save that assembly, load it again, and find out how long it took to load one part and how long it took the other part. So you can see one part took about 4 minutes to load. This one takes about 4 or 5 minutes to load, while the other one takes about 8 seconds to load as part of an assembly. So you know what? I'm a little bit afraid to do it right now, but you know what? Let's give it a try. So I'm gonna go assembly millimeter, create a brand new one. Let me pin this down. I'm gonna put this part in first, and then the one that has no appearances. Okay, so that's one thing I'm gonna do. The other thing that I would like to do is going to the next topic. Before we measure that, I want to add one more member to this assembly. What about simplifying the number of bodies, reducing the number of unnecessary bodies, right? Right now I have a few hundreds, but do I need all of them? maybe not. So let me take this guy and actually one thing that I probably should do is close the other session of SolidWorks, right? Because we already know this works much faster, so we don't need that. And I think the other assembly I can open it easily. Okay, so if you have a glass of water, maybe take a sip as this closes. Actually, I'm gonna close the session completely. Okay, so I have these two parts. This one has lots of appearances, this one has only one. And I want to take this part and save it again. And I'm going to show you one thing, how appearances can be your worst enemy, but also they can be your best friend. It's just a matter of using them as a tool, right? So if a tool is used the right way, it's going to be great. If not, it's going to be pretty bad. So let me save this as a new part and open the new part. And I'm going to call it no appearances optimized. Okay, save. Okay, so I'm just waiting for the new part to be not only saved but loaded in the memory, so you can see it right now. It still has 5,762 surface bodies and 72 solid bodies. So that's madness. Do I need that many? Whoa. Let's keep the original open. So let's simplify this. The problem is, it's very hard to select what you want to delete. Maybe there is a little thing here, but notice when I click here, let me make sure that when I click on something, the feature manager will bring that thing into view, so you guys can see what I'm clicking on. Even though that's gonna slow me down tremendously now, because every time I click, it has to not only to find the thing that I clicked in the feature manager, but to bring it into view, right? So those of you who attended my other presentation, the one that I did with Artem Taturevich on API for large assemblies, you remember we have a little button that can turn on and off this functionality. So, and also it's much faster than doing this manually. You can see how this circle is spinning now, because when you change one setting in system option, guess what? SolidWorks rewrites all the settings, not just the one that you changed. So it's not very efficient, right? So I click on this, you can see it's this feature. But I don't want to delete the part, I want to delete the whole feature. And remember, you don't want to delete bodies, because then, you know, it's going to increase the file size and it's doing a lot of extra work. You want to get rid of the features that you don't need. So since it's so hard to select the ones that I don't need, isn't it easier to select the ones that I need, right? So for example, I click on this, but unfortunately, even though the feature looks selected, I selected a face. So if I press the delete button, actually I don't want to press the delete button, I want to select the opposite of what I'm selecting, kind of inverse selection. It's not gonna give me the inverse selection that I want on the features, it's gonna give me inverse selection on the faces. Okay, you're gonna say, why don't you use this filter option? Press F5, right? So I hope you guys remember F5 allows you to get this toolbar appearing. But there is no filter for features. And we asked SolidWorks for a long time, hey, please add a filter for features. There is none. Okay, how can I select features from the graphic area directly? I don't care about the feature manager, I can actually hide it. And I can even turn that option off, so I can be faster on selection. I don't have to wait for this to go up and down. Well, turns out appearances are a nice way to create selection sets. So I'm gonna click on this face. This face belongs to a feature that I want to keep. So I'm gonna go to the appearance. I'm gonna apply it at the feature level. You can see here imported tree. And by doing that, the appearance command starts, right? So let's pick up a color that works for all of us. I guess orange would do. Notice when I do that, I'm applying it to features. Okay? So what else do I want to keep? I want to keep this feature. So again, I click on this. You can see it's adding it to the selection. I click on this. It's going to add that to the selection. I click on this. I click on this guy. Let's see, is there anything else that would make sense depending on your uses? Like if I want to create maybe a packaging for this, or if I want to create a fixture for this, I might be interested in things that are protruding, right? Like this ones, maybe this one, maybe this one. And you can keep adding stuff by making them orange, maybe this little clip there. And once you're happy with your selection, simply apply it to your features. Now, the crazy thing that happens here is not only the fact that certain features got the orange color, right? So I have 6,000 different features, and it's kind of next to impossible to find. Oh, look at another one, right? But fortunately, I don't have to go and find them this way. The display manager tells me, yes, man, you have a orange color. If you expand this, guess what? I have features. So when I click on this, select all these features. The other tip that I can give you is that if you want to apply this color to other features, another way to do it is to simply copy the appearance from one of the faces into the memory and apply it by pasting that to the feature level. You can see I'm adding one more feature to that list. Good, we did that, right? Now let's click on the orange color. Let's see what happens. So once you select it, what happened in the tree? You can see that certain features are selected, but these are not the ones I need to remove, right? The ones I need to remove are all the other ones. So I'm simply going to right click and go to invert selection. So now instead of having this selected, SOLIDWORKS is going to select everything else in the feature manager. Now if we be ready maybe to go and get a coffee for really complex parts, because sometimes this invert selection can take longer. It also helps if you turn off the scroll selected item into view. So you can see right now how the features that were not orange start to get selected. So again, you can see the huge power of appearances as selection sets. I'm gonna say for many things, especially for features, they are better than the typical selection sets that you have inside SOLIDWORKS. The main advantage is you can apply these appearances directly in the graphic area. And I'm a very visual person, and also I find the graphic area is probably the best, I'm looking for a superlative. It's optimized for performance in SOLIDWORKS, right? So you can see all of them got selected. Now I'm not going to suppress, I'm actually going to delete. So allow me to, you see my finger? Yes, you see my finger. It's going to go to the delete button on my keyboard. It tells me not everything can be deleted, right? Which kind of makes sense. I probably cannot delete the front, the top, the right plane, or the origin. I'll say, okay, I know that, but delete everything else. Let's see what's going to happen. Remember this number, 5,762 plus 72. So that's 5,834, correct? If my math still works. Well, let's see how many bodies I'm going to have in the end. And by the way, everything you see right now is live. This is the investment that you make in making the part better. And this is important because many of you tell me and tell us at Javelin and at TriMac that you know that you have problems with your imported geometry, you know that it's going to slow you down, but it's taking too long, it's going to take you too long to fix it. So let's think about the law of diminishing returns. How much time are you prepared to invest? Are you okay to invest 5 minutes? Are you okay to invest half an hour? If you know that after that, this part is going to open much faster than before, right? So you can see right now I have only 12 bodies left. And if you don't like the orange color, I can always remove it, right? So let's save this. Still looks the same for my purposes. I just removed those small pesky features really fast using appearances. So now let's go back to the assembly that we put together. And let's insert this part also in the assembly. Okay, so let's go and insert component is, good question. Yeah, I think this is the one. Okay. And let's save this assembly. Okay. I'm a bit afraid now. Let's call it comparison. Okay, so let's leave the assembly saving. And after that, we're gonna close SolidWorks and open it again and open the assembly. And probably we're gonna do another thing in parallel so you guys don't get bored with this, right? To save this, I'm gonna close SolidWorks. We're gonna move on to working at an assembly level. So let's do, I'm gonna open 2 sessions of SolidWorks. So one of them is gonna be busy loading this assembly. The other one, we're gonna hopefully be able to do some work as we are waiting. Trying to be as efficient as possible. Actually, that was the beauty of 3D Experience World 2021, because I was having everything in a video. I could reduce some of the waiting times. Okay, so this is gonna be the assembly. I'm not gonna open it yet. Let me open SolidWorks again. So I have 2 sessions running at the same time. And we're gonna let that load. And in the meantime, hopefully we're gonna do something else. Okay, so I have the 2. Let's go in this one and open the assembly. I'm gonna open it resolved. Okay, open. So we're gonna let it open. And on the other SolidWorks, which is this guy, let's open a different assembly. Let's hope I remember where it is. So it's, thank you my friends who are here who donated this assembly to me. You know who you are. I have here an assembly that is based on imported geometry. Again, I'm gonna open it fully resolved. And we're gonna talk about certain techniques that you can use for optimizing assemblies that are coming from step files. Okay, so let's see how long it's gonna take to load this 425 component assembly. Well, you can also already see some of the things. Notice how this body here has some topological errors. And one good question would be, what if you repair the errors? Is it gonna save you a ton of time or not? But let's not even get there. Let's think about how many of these parts are actually required for your purposes, right? So there are 425 of them. Do you really need all of them? So the first thing I would probably be interested in is getting rid of everything that is internal to this assembly. There might be certain components that are not even visible. So take advantage of the advanced selection and use maybe select internal component. So in order for something to qualify it as internal for SolidWorks, it has to be completely enclosed by other faces. Shouldn't be any gap to communicate with the outside air. So you can see quite a few things got selected automatically. If I'm to isolate those, we can reveal what is inside that specific assembly. So you know what, I don't need these guys. This time let's just suppress them. So we had 425 components to start with. This simple operation, what's the return of investment? So let's take a look at the performance evaluation again. And go to the number of resolved components, 241, right? 184 are suppressed. Really cool stuff. And again, thank you again to those of you who gave me this file. It's a great example. Okay, what else can you do? What about selecting small things? So let's go select by size. So this is a pretty interesting tool. You can actually have this checked, so you can see automatically as you type here a percentage, what was the result selection wise. So you can use this slider, you can use these little arrows. You can see with 2% I have 4, or you can type value. 3%, 74 things got selected. You can see these bolts. 4%, 126 things got selected, so I'm getting these ones too and the nuts. 5%, I'm getting, now it becomes a little bit dicey. Do I need these guys or not? You guys decide. If I go to 6%, I think we're getting a little bit too far away. The problem I have right now with this functionality is that I cannot spin the, I cannot really spin the view. So I'll give you a little tip, not related to this course. If you'd like to see this in two different views, there are a couple of ways to do it. One, you can create a new window, or you can show this as a two view, either vertical or horizontal. So in this case, let's go vertical. Now, these ones are linked. These views are linked. I'm gonna unlink them. So this way I can have this, let's say, as ISO, and this way, let's use the selector. I'm gonna try to look from this direction. All right, so I can look, or actually not. Let's look from here. So this way we kind of can see everything. Right? The cool thing about this, if I click on one, obviously this is the same assembly on both sides. So let's try again to select by size. You can see 6% selects quite a lot of stuff that maybe I don't want selected. Let's stay at 5%. So 150 things get selected. I click OK. You want to see those 150? Let's isolate them. Do you need this? If not, let's suppress them. Let's exit isolate and switch back to one viewport. Okay, so this is if you want to do the reduction in a controlled manner. You watch it yourself what you're doing, right? So that's one way to do it. And this is not the end of it. Remember the power of appearances. So just want to check on the PowerPoint just in case we want to keep track. So advanced selections, right? We talked about select internal components, select by size. What about appearances? We played with appearances in parts. Can we use that in assemblies? I don't know. Let's try. So where would you apply the color in order to single out one component of the assembly? Well, I would apply it obviously to the component level. So let's use the same color. I want to keep that, and I want this to be orange. And I want to keep this, and 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 this. Aline, can you select things with a box? I don't know, can I? Let's see. Can I select these guys with a box? Can I select these guys with a box? Yes, I can, right? Over here, I don't want to go with a box because I'm not sure. I don't want to select things that I don't want to. So I'm gonna go one by one. Just be aware that sometimes when you click, if you're too wild, SolidWorks might pick something that you don't want to be picked. And on the bottom or on the back, I want this guy, 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 right? And now I'm just gonna finish applying the colors. Probably I want also, let's do the copy paste thing that we talked about. So copy. I would like to get this tie rods. So the feature level. The other thing you can do, that's a cool one. You can actually add a keyboard shortcut for paste appearance. So I'm going to type here paste. You can see I have Ctrl-Shift-V. Serious? What about Alt-P? Oh yes, I'm going to use Alt-P to paste appearances. So what I'm going to do is this. I'm going to click on this. I'm going to go to the paste appearance button, and then I'm going to pin this down. Okay? So appearance target is going to stay there. Now, the first time you do it, this is a little bit of a bug. SOLIDWORKS applies it to the face. It thinks that you clicked OK, which I didn't. So I'm going to remove it from the face. Okay? So now I'm going to put the appearance target on the feature. I click on this and I'm going to go Alt-P. Select this guy. Alt-P, right? Aline, I don't like keyboard shortcuts. I hate them. Can you use context toolbar or an icon on the context toolbar? Like, can you click on this and find the paste button? Yes, you can, right? So paste appearance. Click, paste, click, paste, right? So you have all kind of options from this point of view. And allow me to say that probably it's enough. I still have maybe 8 clicks. Let's do it with keyboard shortcuts. So 1, 2, 3, 4, 5, 6, 7, and 8. Those are the ones that I want to keep. Let's turn off the appearance target. And let's go to the display manager. Oh, I made a mistake here. For some reason, when I paste the appearance, it actually pasted in separate appearances. So that kind of sucks, right? But that being said, I can do a shift select and then I can run inverse selection. Let's isolate whatever is not orange. Voila, there you go. Let's suppress these guys. And exit isolate. Right, so you can use the same type of techniques that we use at the part level. And then obviously you probably are going to clean up the... Can I select all of them? I think I just did it a moment ago. But if you try to remove, it doesn't work like this. So let's try to remove using delete all display states. So can I do that in... that's a good question. Can I do that in an assembly? Because I can do it in a part, right? Remove all display states. So I don't know. Let's look as a command. If remove, look like in the assembly they didn't give us the option to remove all display states. Fortunately, I can probably go at the top level assembly, and I'm simply going to remove all component appearances. Did I do that? Kind of. Let's remove all appearances in this case. Okay, so that's one way to do it. Looking at the performance evaluation, we started with 425 components, and now we have 58. Actually, there are 57 because the 58 is the top level assembly. Okay, so this is quite a lot of manual work. And still we have a pretty complex assembly. Can we do better than that? Yes. If you have SOLIDWORKS 2020 or 2021, I think also 2019 has the feature silhouette, but 2021 took this to perfection. Okay, so I'm going to show you first of all how to do the same type of selection of what you want to keep without having to do all this mumbo jumbo with colors. So maybe allow me to select everything that's suppressed and set it to resolve. So go back to where we were, right? When we loaded this assembly. I could have also reloaded the assembly. I see a couple of questions, so I'm gonna answer them in a few minutes. Okay. Yeah, looks like unsuppressing might be quite time consuming in this case. It has to also compute the graphics, so we got it back. Okay, so let's do the Defeature silhouette. Like this morning, I showed to some of you who, thank you for joining me earlier in the large assembly service, the Defeature simplified. Now I'm going to talk about Defeature silhouette. So let's go next to select simply things that I would like to keep. And then I'm going to say do not modify them, simply copy the geometry, right? So for example, I would like to get, let's say this part, this part, this part, this part, this part, this one, and this one, and click add group. And I kind of like to keep them grouped together with things that make sense to be together. So really the only thing SolidWorks does, it takes what I selected and it's simply gonna copy them as body into a multi-body part. Because many of you like to save assemblies as parts, which can be a good idea or can be the worst idea you had for your assembly performance, depending on how you do that save. This one is probably one of the best ways to do it. Let's say select all these guys, and again, I'm just simply gonna copy the geometry. Right, what I'm doing right now, I'm trying to replicate what I did earlier, right? I'm gonna select these guys, copy the geometry. I'm gonna get this tree, copy the geometry. I'm gonna get these ones, okay, copy the geometry. And what else did we say we're gonna keep? I think we said we're gonna keep also the tie rods. Right, so let's do that. This guy, and this guy. Copy the geometry. And let's add also this part, this part, this one, this one, this one, this one, this one, this one, this one. Copy the geometry. You might wonder, why did I do this at the end and not at the beginning? This body that has import errors, I want to keep an eye on it, so I put it right at the end. Okay, and you can see the preview. These two views are tied together. What I'm not gonna get there are all the little internal things. Everything that I didn't select are not gonna be here. Go next, and then you have options. You can save it as a new document, or if you have SolidWorks 2021, you can even put it as a configuration inside the main assembly. So I'm going to click OK. Let's see what we get. Just looking at the time, I think we're a bit over time. I apologize for going extra. So as it's doing this saving, let's return to our comparison assembly. Remember that here we had something with lots of appearances, something with one appearance, and something with less bodies. Let's go to performance evaluation and take a look at the opening time. And tell me if this is not crazy. Bang, 320 seconds. That's what, 5 minutes? More than 5 minutes. Versus 10 seconds by deleting, by deleting all the appearances. The geometry is the same. Or 4 seconds by deleting those bodies. So you can see also the law of diminishing returns. So I spend that amount, I spend that amount of time. Oh, what am I doing here? And I got a lot of bang for the buck. And then I spend more time and I got less. So this is the amount of time. This is the improving performance. But even this is huge, is more than twice as fast. All right, so you can see we're able to prove live that performance. Okay, now what happened to going back to the defeatured assembly? It has two configurations. One is the default with everything, and the other one is the feature. And notice I did good to pay attention to that body because it's not there. So I probably need to go to edit the defeature and take a look at the definition for that. So probably I can select it and bring it in there. Okay. Now I want to show you another crazy thing about the feature. Let's see if I have it as a slide. So we talk about the feature silhouette. Oh, and then we go to the takeaways. So let's do it this way. I'm gonna show you the takeaways for those of you who need to leave, and those of you who want to stay for a bit longer as a bonus, I'm gonna give you the cherry on the cake. Okay. So remember, appearances can be your enemies. Always minimize face level appearances. You don't need too much training for this. Just remember, performance evaluation, find the parts with many appearances, get rid of them. Second, appearances can be your friends, right? So use them as selection sets, not just for suppression, deletion. You can use them for a lot of other reasons, like all the components that are red or all the bodies that are red mean something, and the ones that are blue mean something else. I click on red, I suppress everything else. I click on blue, I suppress everything else. Delete face, move body will, in some situation, almost double the file size. Take advantage of advanced selections, and I just showed you 2 tools for advanced selection. There are lots of them, and some of them are fantastic. I strongly suggest taking the assembly course for that. The features can be saved as a configuration in the same file. So that's pretty crazy. Okay. And also I would like to add a quote from one of my favorite clients. Mike Taylor is leading the film Maurer and Associates. And I learned a lot by working with this team. Many of the things that you saw today were learned on the job with people like that. Actually, this is one thing that I like about what my customers are many times telling me. They tell me, oh, this is slow. And I say, take training. And many of them tell me, I don't have time to take training. So you're gonna have to train me on the job. I mean, you're gonna come here, you're gonna shadow me. Whenever I have a question, I ask you, and I'm gonna progress in my job. So this is a service that we also offer. Okay. So think about the law of diminishing returns. How much time you're gonna invest in order to see huge improvements. Okay. And for those of you who would like to get more free training, more free information, as you probably know, we are the leading website for SolidWorks free tips and tricks and other info. Not only SolidWorks, 3D printing, 3D scanning, PLM, PDM, anything you need, just go to our blog or to our YouTube channel. And I hope I'm gonna see many of you in July, regardless where you are on the globe. This is gonna be online in our large assembly and drawing workshop, which is the public version of the large assembly service. It's a bit cheaper, and it's only 4 sessions, so kind of, I think it's 4 hours or 5 hours per session, 4 times. Okay. And also, if you'd like to get in touch with me, this is my email address, and this is pretty much is my name. So if you go on LinkedIn, just look for Alin Vargatu. There might be other Alin Vargatus. I'm the only one, I think, that is crazy about SolidWorks and CAD and engineering in general. So I would be more than happy to link with you there. So that being said, for those of you who are still here, and I see only 3 people left, which is, wow. Let's put a cherry on the cake. What if I would like to, instead of keeping the geometry the way it is, I would like to simplify it drastically. So, allow me to delete all these groups. I'm gonna reselect them, or maybe I can take advantage of them. Let's see. I would probably like to start from scratch. You know why? Because the ones that have been put here are not simplified, so they would be time consuming to deal with. And probably one way to do that probably is to delete let's delete the Defeature configuration, and imagine we start from scratch with this, right? So go back to the default. I'm gonna delete this configuration. Notice I don't have a Defeature feature here. So the configuration itself is the placeholder for the Defeature. I'm going to do it again as from scratch. What's going on there? I might need to restart SolidWorks. Yeah, so things got a little bit crazy there. Allow me to just restart SolidWorks because I had 3 sessions running at the same time, and I think I got too much. I confused windows. And in the meantime, I would like to provide an answer to Loritz. He is asking me if the performance impact from appearances is felt on parts and assemblies, and the answer is yes. If you're taking a look at how long it takes for this part to load, you're gonna find out that just as a part is much longer than that. And the other thing that I haven't tested yet, but I believe the answer is yes. Even appearances that are being applied to, let's say, bodies and features, if you can stay away from that, it's better. But if you need, just make sure you don't apply appearances to faces. Try to apply to everything that's higher up the list, like the whole part or a whole body, or if you need a whole feature, instead of going face, 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 face. Okay? So I'm gonna open this one more time and promise we're gonna finish in about maybe 7-8 minutes. Now I'm pretty sure 3 of you who know me better are gonna say that Alin cannot keep promises in regards to time anyway. So we'll see. Okay, I know it's gonna take another couple of seconds to load the assembly. This contains all the components, right? So let's start the Defeature again. I'm gonna use the silhouette method. And let's say the only thing we care about is a nice space claim for this assembly. We might not even care about mounting holes or something like that for now. If we need, we'll talk about that. So let's say all these parts, this one and 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 this one, can be represented as a bounding box. Imagine the smallest box that can be placed around each and every one of them. I have the option to merge them as one body or leave them separate bodies. Okay, so let's go add group. So now imagine SolidWorks is putting does almost like a convert entity. It's called silhouette entities on those parts and extrude them through all until it touches the end of the part, really, of the body in that case, or the part, right? So you can see these ones. Okay, what else? What about these guys? Let's simplify them using the cylinder option. Right, so you can see them there. Okay, what about these guys? Let's simplify them also using the cylinder option. Okay, cool. What about this, and this? Now, these ones have some holes. Now, the holes are not important, but just as a teaching moment, what if I wanted to preserve those holes? So instead of using the bounding box, I'm going to use the polygon outline. Sorry, the tight fit outline. And I'm going to keep the internal loops. If there are any holes in here, I want to be preserved. The question is, from what direction am I doing this convert entities or silhouette entities? So let's pick up a certain direction. Let's go normal to, I don't know, this face, for example. Okay. Now I can also trust SolidWorks to attempt to pick the correct direction, but you can control it. So I'm going to add this as a group. So let's take a look at the result. Imagine it's going to be kind of the stamp, the footprint of this part, including any holes that are going to be in there. If you choose this, it's a bit more time consuming. Right, so you can see here I have the holes. This one actually has a big hole inside and they got preserved. And you'll kind of get the fillets over here. Okay, What else? Let's get this one, and this one as cylinders. Same thing for cylinders, you can pick up the direction of projection. Now, the fun part. I'm gonna select this one and this one. And imagine I selected all the other ones, but I want to save you time, so I'm gonna select only these two. I would like to project them from this direction, right? So I'm gonna use the option tight fit outline, and let's do a projection from this direction and add a group. You can also select a plane, but right now I don't trust these planes to be oriented properly, so that's why I selected that face. What do you see here? Isn't this cool? Just was able to simplify it. Kind of an actual extrusion with the outline that you wanted. The last one, I'm gonna do it a bit crazier. So I'm gonna select this one. And this time I would like to project it in 3 different directions to create 3 bodies and find the common space between them, running a combined common, right? Guess what? Defeature can do that for you. So I can say tight fit outline, use multiple directions, and for one of them I pick this one. The other 2 are orthogonal to this one. So add a group. Now this takes a bit longer, right? Because I need to do all these projections. And the result is right there. Next, let's create a new configuration. If I want, I can also include the front, top, right, and origin in that new configuration. And now this gets sucked inside the assembly. Can you do that in 2020? Yes, but you have to do a bit of manual work. So, well, we'll talk about that probably in the class, because it's a bit more than I can tell you right now. Too bad we don't have the time to show you how manually I can simplify this part. I can obtain the same thing manually in a few seconds without running the feature. So if I get this as a part, how I can go from here, from this shape, to this simplify shape, where you're simply projecting 3 sketches from 3 directions and you keep the common space. Now, if I am to test how much faster it opens compared to this, I'm not going to do the test right now, but it's crazy fast. It's unbelievably much faster, right? Also, you have options. If you want, you can save this as a multi-body part and then maybe do patterns after the fact, so you don't have to deal with the feature. There are lots of things that you can do from here. You can add the holes, the mounting holes, you can do lots of other things. So Mario is telling me to keep talking, but he said that 6 minutes ago. Maybe he's now fed up with this. Yeah, I can keep talking, absolutely, and I strongly suggest you come and spend some time with me on my workshop, on our workshop at TryMac Javelin, and you're gonna see me talking a lot, but also you're gonna hear yourself talking a lot, because this is not a one-way delivery like we do in this webinar. We're gonna be very curious on our side about what matters to you. You're gonna tell us what you already know. We're gonna learn from each other, and in the end, all of us are gonna be smarter and more knowledgeable. Let's see what questions we have here. How much do those Defeature configuration affect the performance? I'm gonna say almost no effect. So imagine I'm inserting this into another assembly, right? And I'm using the Defeature configuration. Okay? As long, there is one caveat here that we cover in the large assembly workshop. It's very important to have this check mark. So even if I'm in the default, I have to have a check mark here for the body data to be computed, because if it's not, guess what? SOLIDWORKS is going to have to calculate it from somewhere, and it calculates it from the default. So I'm going to do an experiment now, Loritz. I'm going to save this with the default configuration on. Okay, so save. Looks like we already started our workshop. That's exactly what happened in all my courses. People ask me, what if? Can you try that? Try this. Okay, so we save this, and let's save this guy too. So save. What name should we give it? Let's call it SEM1. So I'm gonna close this. And let's open just the Assemb1. Ooh, look at that, 2 seconds. Isn't this crazy? Makes sense, right? Because what SolidWorks does, many people think if a file size is huge, SolidWorks loads that huge file in the memory. So if a file has 100 meg, a part file or an assembly, oh my God, what are we gonna do? We have 100 meg. Let's purge configuration data. Let's do all kind of crazy things. No, don't do that. SolidWorks simply goes in the file and extracts only what it needs for that specific moment in time. So in this case, for this assembly, it just went to the big file and picked up only the configuration body data for this configuration. So very smart, very efficient. Okay. Any other questions? Okay, if there are no other questions, I want to say how grateful you are that you joined us, especially those of you who are joining for the 4th time. And I want to say many thanks to Paige. Paige is my colleague who organized this. She sent all the emails, she invited you, and she actually facilitated this webinar. So many thanks, Paige.
Thanks so much, Lynn.
And I hope we're gonna have a chance to see each other again in either in the next webinar or even better, in the next workshop. And I know some of you, I have a meeting next week anyway. So that being said, have a nice evening or nice morning or nice afternoon, depending on where you are. And don't be strangers. We love you here at Javelin. Bye.